This is the center of the loop, and this is the rod. It is okay. Let's take the this is O A B. Is asking how much of EMF induced potential difference between points A B. And B bar is everywhere into the plane. So instead of showing everywhere, I'm just putting it one point. So this dB by dt is alpha. Let's begin with the problem. How to calculate only this AB? Now we have a loop OA and OB. Now I'm going to introduce, or I'm going to discuss a very good information regarding this. This one. First, shall we take OAB as a one loop? Treat OAB as a loop. Then let's calculate the flux linking the loop OAB. EOAB. So for that, what I should write? SOAB dB by dt. What is the area of that triangle? Of into, so that this we have, he has given length L and R is the radius. Anybody? Area of triangle? L square by 4.
Sir, L square by 2 root 3.
In terms of L, L square by
2 root 3.
Cost 2 root 3. Okay, there's the area of triangle. dB by dt is what? Alpha. I think till here no problem. EOAB, you write it. And then again, what we should do? We should find out EMF induced in each side. Then I'll get the EAB. I think there's this logic, no? What we tried in previous problem. Okay, let's look at the diagram here now. How E bar will be? Come to the Lenz's law. Faraday's law, first Lenz's law. B bar into the plane, negative flux increases, d phi by dt negative, EMF induced positive. So everywhere it should be tangential to the circle drawn in that, and we will produce such magnetic field only solenoid. Inside the solenoid, we are discussing what is this inside the solenoid, because solenoid will not produce the field in the cylindrical region of radius r. So a magnetic field will be varying, and how to produce that varying magnetic field already we have discussed, like B equal to mu naught Ni. If I send a variable current, it will produce. This is the background, always keep in mind. And all our problems related to like a solenoid field produced by solenoid only, because other structures cannot produce field. I cannot produce a time varying field. Solenoid is the easiest one. That's why all our problems are confined to circular magnetic field only. And now how E bar will be directed at various points. So I'm interested at OA. I'm interested only at OA first. How E bar? So shall I put it like this? The direction. I'll show few lines. It will be like this. E bar will be directed here. This will be the direction of E bar. And how you take DL, the DL you are going to take it in the direction. So for what is the E bar DL here? 90 degree. So what is EMF induced EOA? Should be equal to integral of E bar dot DL. So some value E is there, some value it is having. So DL cos 90, no? At all points on 90, no? So no EMF induced across the side OE. Let's similarly come for OB. Even for OB also similar thing. So how E bar will be directed? Everywhere tangential. So like here it will be perpendicular to this. You have plenty of numericals based on this basic concept. No, here also you look at how DL, DL you're going to measure along OE. So what is the angle between them? EDL cos 90. Some value, it may not be E. I think we know as you move away, the E bar will increase, no? First problems. How, and on the circumference will be maximum. Again, it start decreasing. You must have background, I'm telling this one. Here, induced electric will be zero. As you move away, what happens? The induced electric field magnitude will increase and all be directed everywhere tangential. And outside what will be again, you draw a circle tangent to it, the magnitude will be decreasing. Is it okay? There's a firm conclusion. Have this background. It'll be very easy to work out all these problems. Sir, I want E bar here. Put like this. It's not that only some specific points. Everywhere you can show it. There's the direction of E bar. Draw a circle, draw a tangent. So here also we can show it. But length of the arrow should move away as you move radially. But outside here again will decreases here. Here it will be maximum. Again it should decrease. Why it should decrease? Because from the formula, like this till infinity to extend. Till infinity. From here till infinity, the induced electric field will be there. Now will be directed perpendicular line joining OC. Have a very generalized idea because so many numericals will be related to this information. So like this, what I should do, I should keep on decrease the magnitude of E bar. Not only till C, we can continue till here like this. Fine. So what is EMF induced in the rod OB is also zero. So then what is total EMF induced? EOB should be equal to EOE plus EOB plus EAB. These two are 0 plus EAB. Electric field should be perpendicular to the circle, tangent drawn to the circle, no? Because how the induced current will flow, if any some conducting wire is there, how induced current will flow along the circumference of that ring. Then who will make it to move? The induced electric field only. So therefore you have to draw a circle, draw a tangent. This is very important. Without this background, you will be in a big trouble. Instead of doing all problems, at least to do one problem and understand things first. The induced electric field should be tangential, means in a region if magnetic field is varying here, V bar is varying everywhere, you have to draw a tangent. Then sir, I want here. Like this, it will be. Draw a circle, draw a tangent. So finally, what is EAB should be equal to EOAB only. This should be equal to L square alpha by 2 root 3. Now I want for this particular thing, for the total rod AC, how to do? We will calculate that also because anyway problem is available. No? For EAB we calculated, I want EAC. I want EAC. Again, EOA and EOC will be 0, no? Then EAC, how to calculate EAC, but we don't know the area, no? So where the flux is linking, the flux is effective area, you have to take this one. So what is the effective area of triangle plus area of sector? Getting the idea? So the effective area, what all it will come? It will be, I don't have space. Yeah. I'll continue the next part of the problem here. We are now taking for the total triangle OAC. So what is the formula will be? EABC. This has to be determined. For that, what I do is EOA plus EABC plus EOC should be equal to EABC. But this is equal to 0. Any reason? And EOC will be 0 because everywhere E bar perpendicular to DL. OAC. Yeah? So EOAC. EOACO. Total triangle. Okay, I'm changing symbols. Some of you are getting confused with, sir, what is triangular total, that one. Is it okay now? Now come for this. For the rod, ABC has to be determined. So can we calculate what is area? But here also, there is no magnetic field here, no? And magnetic field is present only in this region. And it's everywhere, but our this one, how to calculate this area. So I'll call this as point P. This one. So area of triangle plus area of sector. So so the effective area, this will be E O A B C O. A B C O. And this is now. So how to calculate this one? Area of triangle SOABO SOABO plus SOBPO. I'm writing in small letters into dB by dt. Let's write it. Area of triangle, already we know it, no? L square 2 root 3. What is area of sector? Half r square theta. So r square angle pi by 6 into this is alpha. And this should be equal to EABC. Able to make it out now? So now effective area in the lens in the Faraday's law, E equal to S dB by dt. Here S is not area of triangle OABCO because the field is present only in this region. Here no field. So I'll write it some other letter. Okay, some other color. No field here. And the field is present in this region. So this is one triangle what you get.